This is a short description on how to use an automated melting point apparatus. The first thing you want to do before inputting any parameters is to find out the theoretical value for the melting point of your sample of interest. We do this by consulting Wikipedia, PubChem, ChemSpider, ChemDraw, any reasonably authoritative database. As an example, I'm going to use maleic anhydride. So for maleic anhydride, which looks something like this, I want to find out what the theoretical or what the literature value, the literature value for the melting point is. So taking a look at Wikipedia, we find that the melting point is 52.8 degrees. So it melts at 52.8 degrees centigrade. Make sure when you look this up that it's in centigrade, or convert to centigrade if it's in Kelvin, because the apparatus only allows you to put degrees centigrade. So it's 52.8. We want to ensure that we reach a temperature around 52.8 for a sample that we've synthesized. So to do this, I'm going to set a temperature 4 degrees below this to begin heating. So somewhere 47.2, I think that'll work. 47.2 is where I will start heating the sample, and I will finish heating the sample about 4 degrees beyond the 52.8. So somewhere in the area of 56.8 degrees. So that's going to be the range over which we heat the sample. Now, what is this? If you were to look at a melting point range for this compound, so it's reported as 52.8. On the actual container that I'm using in lab, it reports a temperature of 51 degrees, and then it reports 56. So that's called a melting point range. You see the difference between the two? This reports 52.8. This is a melting point range, and that's what I want to ensure that I have. So actually, I'm looking at 47 to 56, because the range of the melting point, 51 represents the first drop of liquid which is formed, and the 56 represents the last bit of solid to melt. And that range gives you the temperature range, or the melting point range for your sample. So in this case, because I know that range, this is the setting that I'm going to use. And by doing this, it will also help you see how we use the instrument. All right, folks, so here are the two automated melting point instruments that we're going to use. One's called an Easy Melt, and the other one's an OptiMelt. The only difference is this is a touchscreen, and this you actually have to push the buttons. Okay, so those are the two. We only have two, and we have 8 students. So that means 4 students per instrument. Now, this is an older, even looks like a dinosaur, right? It's an older melting point. Some of the universities still use this. So a lot of disadvantage. I mean, there's no cooling fan, so you simply have to wait until it cools. And the other thing is that this gets really hot. There's a light bulb in there, so if you get too close, you're going to burn yourself on this. You look through an observation port, and you can see there's a sample in there, whether you can see that white solid or not. And you observe where the sample melts as you direct heat to the sample. So the first drop of liquid which is formed, you write that down in your notebook, and then you continue to watch. And the last bit of solid that melts, you look up here, record that temperature, write that down in your laboratory notebook. So rather archaic in its design. So we go over to this one. This is the more modern. This is an Easy Melt, as I said before. So we're going to input the start temperature where we begin heating and the stop temperature. And I already gave you those numbers. I think it was 46 to 61. So if you press the set button, you see how it changes? Start, rate, stop. So So you can just toggle through that. What you see now is the actual temperature in the instrument. So let's go through this again. 43, we said 47. So one of these two will increase. And you can, if you look really carefully, it says, it shows you an arrow going up, right? Increase. So we said 47, that'd be 4. I think we did 5 degrees. 46, the rate is 1 degree. Usually, the slower the rate, the more accurate your results will be, but the more time it's going to take. So 1 minute, that gives you a reasonable rate. It'll take you about 10 minutes to determine a melting point. The stop temperature, 65. This said, what, 56? So that should be 61. So start temperature was 46. Rate is a degree per minute. Stop is 61. Looks good. Now we're ready to make up the sample. I'm going to set the temperatures on the other one just to show you. It's really easy, right? So you're here, you look over here, it says start, press this one, and you just enter it. I think it said 47, or 46, excuse me, 46, accept. You can see that, good. And the stop temperature, we said it's going to be 61, accept. That's good to go. Now we simply press the heat. That will bring it up to the temperature. The temperature which is shown there is the temperature of the device. It'll probably cool to room temperature if it sits there long enough. But I want to bring it up rapidly to my start temperature. So you press the heat, and it will beep when it's done. And you'll see the green button here, which will illuminate. And that means it's safe to put your sample in. You don't want to put the sample in until you reach the start temperature. The same thing with this one. So we're going to press the start button. That's going to bring it up to the appropriate start temperature, and then this will illuminate and it will say insert samples. All right, so let's take a look at the preparation of our sample. I'm going to pause the, okay, so now we're ready to prepare our sample. I wear gloves. You know, you may be allergic. Some students are allergic to caffeine and other chemicals. So wear gloves, take your sample. You've already prepared this for your caffeine. Melting point tubes look something like this. I'm sure you heard the sound in the background there, which tells you can insert the sample. So there's a melting point tube. Check to make sure it's sealed on one end and it's open on the other end. So the open end obviously goes into the sample. You only need 3 or 4 millimeters of sample. You can tap it on the bench top. You can see this. That's about 3 millimeters. That's going to be fine. The way the instrument works is it actually passes a beam of radiation through the sample. And of course, it's going to be opaque. As soon as it becomes transparent, radiation gets through and it creates a signal. So it's kind of cool. All right, that looks good. That's one sample. I'm going to make up another sample on both of the instruments. Now, if the sample sticks to the sides and doesn't go into the tube, that means it's probably a little damp. It's probably got some moisture in there. So ensure your sample is completely dry before you try doing this. Looks good. So I've got the 2 samples prepared. Lid goes back on the container. Make sure this doesn't get spilled. I'm going to pause the video. I guess not. We're not going to pause the video. All right. So place the samples at the top. By the way, there's the button, right? Insert samples. That's great. Go up here. This is left over from before. This comes out into the waste. And then just put this, there you go. You can't see the sample because of the glare, but it's in there. So check to make sure you can see the sample. Over here, you see the ready button is on, and we're ready to start, but I don't want to start until I put my sample in. Now that's not in. If you look in the window, you won't see the sample. So because this is a little bit newer instrument, there's some snugness there with me. So just push it down gently. Now we're cooking. Now we can see the sample in there. All right. Looking good. So we can, over here, the sample's inserted. We'll press the start. Over here, everything's good to go. Sample's inserted, press the start. Now it's on its own. So it will measure the melting points. It'll record the melting point range. And then you'll hear a sound, the beeping sound. It will tell you the analysis is finished. So we're going to put this on pause. Alrighty, folks. So I've heard the beeping sound. The melting point determination is finished. And you'll hear the fans going on. So it's cooling back down to the start temperature, the start heating temperature. Notice that the data is flashing. That means we have data in there. So I'm going to go over here and press where's the sample? It's in the left. And 52.8 must be the start temperature of where it melted. 55.2 is where it stopped melting. So press it again. 52.8, so it gives you the melting point range. It's 52.8 to 55.2. So if you subtract the 2, that gives you the number of degrees in terms of the melting point range. So this is what you report, that melting point range. All right, let's go over to this one. So in this case, we want the report, which is here. Press the report. And if you look carefully, it gives you 52.1 to 55.3. Close. Not exactly the same, but the instrument has not been calibrated. The question is the temperature that you're seeing the exact temperature measured? We'd have to put a standard sample in there and correct for any deviation in the melting point detection temperature. So that hasn't been done. This is pretty good for our use, but if you were using as an industry, like in the pharmaceutical industry, where you were measuring the purity of a pharmaceutical sample, then you would want to make sure that the instrument had been calibrated. So there's the report. We didn't do a graph on this, which is kind of nice. So that's something that this does, which the other does not. I don't know whether you can see that. Yeah, there's a graph. And actually, there is a video stored in the instrument which you can download to your computer. So that's why the OptiMelt, offers you more parameters than the other, but it's a lot more expensive. Okay, well, we're almost done. You don't want to leave your melting point tube in there, right? So this goes out into the waste. So just be careful when you take this out so it doesn't snap off. Gently remove it into the waste, and it's all set for the next student. All right.